Hi, this is Victor and welcome back to my math tutoring channel. In this video, we will study that improper integral and we will find if it converges or if it diverges. And if it converges, we will find the convergence point. But before we start, as usual, I'll give you like a small explanation. Why do we call an integral an improper? An integral is called improper if one of its boundary is equal to infinity. So the lower boundary here is minus infinity and the upper boundary is plus infinity. It is enough to have one of those two equal infinity to be called improper. The second condition for an integral to be improper, if I have integral of dx, let's say for divided by x minus 1. So I know we cannot divide by 0, so x equal to 1 is a vertical asymptote. So that means it is that function is discontinued at 1, so that would be an improper integral too. This one will be improper too. So now that you know what is improper integral, let's start solving this problem. So I know I can write this integral, the integral between minus infinity and plus infinity of x e to the power minus x squared dx is equal integral between minus infinity and 0 of x e to the power minus x squared dx plus 0 to plus infinity x e to the power minus x squared dx. And now let's solve them one integral at a time. I will start with this integral here. So I will take between minus infinity and 0 of x e to the power minus x squared dx is equal to the limit when t goes to minus infinity of between t and 0 of x e to the power minus x squared dx. And here I can say let u equal minus x squared. So my du is equal minus 2x dx, but as you can see here, in my integral I have x dx. I don't have minus 2x dx, so all what I have to do is divide here by minus 2 and divide there by minus 2. So I can simplify the minus 2 on the right hand side. I would have x dx is equal minus 1/2 du. So my integral would be the limit when t goes to minus infinity between t and 0. Instead of x dx, I can put minus 1/2 du. I put minus 1/2 outside my integral because it's a constant, and e to the power of u. But we know the integral of e to the power of u is e to the power of u, so it will become minus 1/2 e to the power of u between t and 0, and let's replace u by its value is equal minus 1/2 e to the power of minus x squared between t and 0. So the first time it would be e to the power of minus 0 squared is e to the power of 0 minus, and here there is a limit when t goes to minus infinity, and here too limit when t goes to minus infinity. And instead of writing e to the power minus x2, I can write it 1 over e to the power x squared, but I replace x by t squared, and when t goes to infinity that goes to 0. So my answer here, it becomes minus 1/2. E to the power of 0 is 1. 1 times minus 1/2, it is equal to 1/2. And that would be the answer for this integral here. Now let's work on the second one here. And the second one is integral between 0 and plus infinity of x e to the power minus x squared dx. And again, if I said it is equal to the limit when t goes to plus infinity, this time between 0 and t of x e to the power of minus x squared dx. This is a t here. And again, if I say u equal minus x squared, and du will be equal or actually minus 1/2 du is equal x dx. So it will become the integral of e to the power of u. And the integral of e to the power of u is e to the power of u. So that integral will become e to the power of u between 0 and t. And the limit when t goes to plus infinity, it is equal to the limit when t goes to plus infinity of, not integral here, it's a parenthesis, e to the power minus x square between 0 and t. It is equal to the limit when t goes to plus infinity. Instead of e to the power of x square, I can put e to the power 1 over e to the power x square between 0 and t. So the first time is equal, when t goes to infinity, it's equal 1 divided by infinity. And there is minus 1/2 here. The minus 1/2, I should put it minus 1/2, minus 1/2, minus 1/2. It's the same logic like before. When t goes to infinity, it becomes 1 minus infinity minus 1 divided by e to the power of 0. So this would go to 0 because 1 divided by infinity is equal to 0. So minus 1/2 times minus 1, because e to the power of 0 is equal to 1. So I become minus times minus plus 1/2. So to solve that problem between minus infinity and plus infinity of x, e to the power minus x squared dx is equal minus 1/2 plus 1/2 is equal to 0. So that integral converge towards 0. And that would be the solution. If you like my video, please subscribe to my channel. That would help me tremendously. And if you push the like button, I would really appreciate it. Thank you for listening.